Okay, so in this tutorial, I'm going to go over schedulers in Inesis and talk about how they work. Basically, schedulers will make these trees grow. So these trees that are just randomly growing. That's what the schedulers do. And let's go ahead and show how these work and how we can modify these to kind of make them do some more things in Inesis and have some fun with them. So I'm going to close this all down. So the schedules are a shared class here, and they're pretty confusing at first, but once you understand them, they're pretty straightforward. So you have the scheduler object, which kind of extends the schedule object parts. Each one of these is one object, and basically all it does is create a bunch of schedulers, and then every now and then, based on the number of milliseconds, it will call this schedule update and schedule update changed functions. So when it's initialized, it creates one scheduler, which is every 15 seconds, and it starts it. There's a none, which isn't currently used, but you could use that if you wanted to. But basically, it starts up with a scheduler that every 15 seconds it does an event, and that's handled by object update, schedule update, and let's go over how that works. So in this example, we're looking at the trees. So the trees have the schedule update function. So this is slightly modified, so just don't worry about that. We'll talk about that later. But basically, it has a flat called growth, and what growth does is everything the scheduler happens, it's going to raise the growth by a certain amount, and then update the matrix with the here in the matrix you can see that it's scaled by the growth factor, which is here in scale. So you can see it scales it kind of randomly between 1.3 and 10 by the growth factor and the stepping growth. So 10 is the greatest it'll be in this case. It may be different in yours. I apologize. I messed with this a bit, but it basically scales here, and then when the matrix is called, it sets the scale based on that. So what's important to understand about schedules is how it works in the client-server environment. I put a small little thing here together. So the server calls schedule update, which I mentioned before, every 15 seconds. It calls schedule update schedule update, which sets the growth value, and then it calls schedule update changed. Here you can see first it sets a growth value and then calls this function. And this function is defined here in the objects root class. So this all objects inherit object. And here basically all it does is call changed. You could overlap that with more calls if you want to, but right now it's just changed, which is defined here. And it checks if it's a ground object, it calls area.ground object changed. If it's not a ground object, it calls area.change area object. So this is the one for trees that we're looking at. And let's go actually into our area class and see what that looks like. So next, it calls the server write ground objects function, and all this does is called the compressed state function, which in tree is down here. All it does basically is add the growth to compression and send that across. So the only variable we have on trees from the server to client is growth. So once it updates the growth, go back to this diagram. Here it updates the growth, and then it says I've updated this tree, calls a change, it's changing ground object, tells it to write it to all the clients, and then compresses the state, which is growth, and in preparation to distribute to all the clients. So the server is pretty straightforward, updates the height and then the growth and sends it across. Now the client, once it receives this compressed state, jumps straight into the decompressed state state function. So that, and hopping over to the client quickly, in the tree, you can see decompressed state. Again, I apologize if it's slightly different than yours, but it decompresses the growth and then sets the schedule so that it continues on its cycle every 15 seconds to refresh. And set matrix is important. This basically, again, as I mentioned, takes the scale, so what the new growth is, because it loaded the growth in from the file, and grows the tree. So when you see them flashing higher and higher, the set matrix does that for you. and it's called from this decompress state function. I've added this. We'll get into that in 1 second. So that kind of explains how this works. Again, it does the decompress state, set matrix, which sets a new growth to it, and then create actor, which I'll talk about in a second. So these are the two that it does out of the box, which makes it grow. Now, what I wanted to do was, currently when it gets to maximum growth, it just stops growing, which is kind of boring. So I thought it'd be cool to make it so that the tree changes into a brand new mesh, into a full-fledged tree once it grows to its maximum potential. So I've changed to 150 to make it grow faster for this tutorial. I think it's at like 256 now. So the only reason these are lower is because I want to make them grow faster. So don't worry about that too much. But I have loaded in a generic tree mesh here. Nothing fancy. It's available on most sites. So it's just a tree object of type static. So it'll load in the same way all my other objects do. And let's go ahead and show you how you can go from this little stump that is the end of the growth, to this from server to client. So that's the next step. So actually accomplishing this is relatively straightforward. I was surprised how easy it was. So hopping back into code, again, there's two places we need to change this mesh. We need to change it on the server and on the client. Go back to my diagram. The server calls the schedule update function, and the client calls the decompress state function. So these are the two places we need to actually make the changes so that it reflects correctly on the server and the client. So doing the server first, I mentioned it is schedule update. So this is what happens. It grows until I think it's 256 by default. Let's see. Yeah, 256 by default. So 255. I've changed it slightly, so you can copy my code. Feel free to do that. But essentially, I've made it quicker. So once it hits what I'm calling the max, which is 150, it'll fall into this if loop right here. And what it does is delete the current actor, and then create a brand in the set the object to this new object pointer, which is my giant tree we showed you earlier. This one. Just by dragging the UID down, and then create actor. So create actor, as you can see right here, basically takes the object, sets the physics, sets the growth, sets the mesh and the matrix, everything here for you. I also, that's all I did really, just add this piece here. So this is what we'll add it to the server, which won't do us a lot of good because we want to see it on the client as well. So the client is first initiated with this decompressed state function. So I did the exact same thing here. So the client will get the update. So once it hits 150, delete the current actor, reset the object, and then create the new actor. That's really all that I had to do to get this to work. It was actually surprisingly easy. Let's go ahead and see it in action now. So if I go ahead and do this, let's turn my server up. So let's watch these trees grow. I apologize for the delay. Should only be a few seconds. You can see it growing much more quickly now because I have them set at a quicker growth rate. But once it hits that 150 rate, you'll see they'll start popping in randomly to the new mesh that I created. And this is a really cool function. What you could do for me is basically start as a sapling. You create a little sapling mesh and start with that, then do this little intermediate one, and then do the full-fledged one. So you can do a lot with this exact same architecture just based on what the growth value is, resubmitting the mesh each time. And it's a pretty easy way to do things. It doesn't send a lot of data. It's very clean. Again, Inesis is very well designed. I'm very impressed with the more and more I learn about it, the more I can see. So there's the first one, and the physics is still be intact. So you can see they're all popping in now. So the shadows are there. Everything worked really well. They just work. Last one should pop in. So you can see, I can move my camera over here and see it as well in the upper right hand corner. So it worked really well. And if I log back in again, the state should be preserved because again I've set it on the server. So now that the server has a new mesh, any new clients that log in should see that giant tree. Yep, and you can see they're still set there. So all new clients will see this as well, which is awesome. So that's what I wanted to show you about trees. But what I also want to show you in the next piece of the second half of this tutorial is let's create a brand new scheduled object and see what we can do with that. Just to learn how scheduling works a little bit better. So let's jump straight into that now. So my goal in the second half is to close this down. It's basically to create a brand new scheduled object. And what I've chosen to do is I have one of these little barrels from the Esenthel general library. I want to make it jump up and down. That's all I really want to do is make this barrel jump every 20 seconds. It sounds pretty straightforward. It was pretty hard for me to figure out, but now that I've figured it out, it's really very easy. So using the exact same framework we have for the trees, I'm just going to do this. So the first thing to do is copy this tree, and let's call it jumper. So it's base class that just jumps. And I need to start by deleting half of these objects. I'm not going to need a lot of this stuff, so if I go to this area, I'm not going to need growth. It's not going to grow. I guess I need there. We'll get back to the scale function. I don't need anymore either because I'm not going to be scaling it along with growth. So we can delete that as well. Set matrix we'll get back to. Get coverage I'm not going to need. It's not a tree anymore. Create should work fine for me. What else do I need? Create and delete actor. I'll come back to the actor in a second. Should delete some stuff. I don't want 15 seconds. Let's go ahead and create a quick new scheduler. So into scheduler function, I'm going to create a quick enum here. I'm going to call it schedule 20 seconds, which would be my 20-second scheduler. And during startup, I want to initialize it. 20 seconds and 20 seconds. That will initialize a new scheduler for me. Alright, so going back. What else do I need? To the active schedule update. I'm not going to need any of this, so I'll rewrite all of this. Second. Draw I want, draw shadow I want, save I want, load I want. With save, I don't need to save growth because it doesn't exist. Don't need to compress or load growth. Decompress growth. Compress straight, no growth, so I don't even need to do this at all. No growth here. And I don't need to increase my mesh. So, and I want to call this a memory of jumpers. And call it jumpers. Oh, Inesis, don't I? Can't deconstruct a tree with a jumper. Case sensitive. Scale. I have to create a scale function as well. So let's actually just delete this whole thing because we're going to rewrite this anyway. Growth here. So I'm actually the create active function also going to have to rewrite. Set schedule. I want to do schedulers 20. and don't just do this if statement. I should do just a little call to the function. Okay, successful. So now we have our base. Let's start filling out the stuff we didn't do. Okay, so the first thing I'm going to want to do is create some variables. We had growth here before, but we need some more stuff for the barrels. This is not actually a tree. So because I want it to go up and down in a linear manner and not just straight up, straight down, I want a time variable to be in here as a float. And how high it is in the air in the y-axis, I want to have that as well. So vector y 0.0f. So just initializing two values there. Structures there. Set matrix. So the set matrix function we have to rewrite. So in a tree, we had this whole problem where it was setting the scale. But what we want to do in the jumper class is slightly different. So same kind of thing where on the rotation, I've removed the scale portion, and basically I've added this vector y to the y-axis. So what it's going to do is going to add the current position plus this y vector, which will start at 0. So it will be at ground level in the beginning, but it will move up based on what the vector y is. So set matrix just basically modifies the matrix of this jumper class. Okay, so in what I also am missing is that because I want it to happen over time, I'm going to need an update function. Now the object class actually has an update function here as virtual, so I can tap into that, which is nice. So let's create our update function here, just to have it there. So I don't have anything to put in there right now, but we'll put a placeholder there. Kind of scrolling down, in my create function I need to rewrite that as well. So previously, that's great. It was doing things I didn't need to do. I want to do something very similar to the trees. I have the same object, same parameter, so it actually doesn't change from the tree. It's exactly the same as the tree create parameter. So that's the same as there. I think we just did that last time. Active and delete. I want schedulers, 20-second scheduler instead of the 15-second scheduler we decided on. So as I mentioned before, the create actor function we need to rewrite. So before it was doing a lot of stuff with the scale and the tree, so this needs to be written from scratch. And the way you can think of this is basically just the actor of the barrel we're going to create. So it's very similar. The first thing we do is set matrix, which is same as the tree before. So in the tree, first thing we do is set matrix. So the object physics, create the object physics, set the average scale. Now this is really important here. In the actor.create function, you want to set the density to 1. The scale can be 1 or average scale, it's your choice. Actually just to 1, it would work just fine too. But what's very important here is to set kinematic to true. This is what makes it so that it loops into your update function. Otherwise, if this is false, it won't ever call the update function. And it allows you to have things where the actor and the mesh move together and have collision. So that's very, very important. The matrix we want to normalize, and also we want to add it to a group so that adds collision. The trees I think are in something called AG tree. Yep, they are. I added this to AG static, which is a standard group that Esenthel always adds. So AG static, so that it will basically collide with everything. So the create actor function, you want to make sure you get that right, because it will cause issues if you don't. The schedule we have 20 seconds, which we like. Next is the schedule update function, which I also have to completely rewrite because it did not work the same way as a tree. It's fairly similar. Here's what I wrote basically: if object is same, little log statement here, but set schedule first thing. So once it happens, you want to put it back in the scheduler again. And what you want to do is set this time value we created up here. So this function of get gets called by the server, and it says, hey, 20 seconds has gone by, it's time to update. So at that point I want to say, okay, lock this time in, and we'll send this to the client so they know exactly when this should happen. So time here set to real time, not the game time, because it's a MMO, so you don't want to use game time, just real time. And that should work for us there. The next is drawing, I'm not going to change that. Save, not going to change that. Load, not going to change that. You could add, I guess, time and state to that if you wanted to. It doesn't seem that important to me. So the next functions we have to update are the compress state and the decompress state. Before it was updating growth. Since we don't have growth anymore, actually all we're going to do is update the time and put that into the compression. Same thing when it decompresses. You want to make sure to grab the time as well. So the first thing we're going to do is actually in this case, so there's one actually kind of funny thing here is that because this is being updated by the function that it comes from the server, and the update function is actually from the client. I found that passing the time in actually is not a good idea. The better idea, because time starts with the client, the number of frames that happened since the start, not stop by pause. If we go here to the time.realtime, you'll see it's based on the number of frames that started since time. You could use current time. If you don't want to do, you could open up for time hacking. So real time still works, but because the decompress comes when you basically want to, in this case, move the object, I'm going to just do the same thing as I did up here and set the time at real time on the client. So again, this is the server and this is the client. I'm just going to reset it here. And I'm still going to set the schedule like the tree did. Still set the matrix like the tree did, and then return. So what this will do is basically come up to the matrix and set the new vector y, and in the next update it will take that new vector y, which while we're here we might as well fill in our update statement. So now we have all the pieces available. Let's go and fill in update. So first what we're going to do is, again, this is on the client, don't forget. So the server doesn't do update, just the client. So we're going to put that delta, which is the real time minus the time that was saved here. And now we're going to find out if the time equals 0, which means it hasn't been updated yet, just skip. So you can skip that if time equals 0. However, it doesn't. For delta, I found that, again, there's a very minor, less than 0.001 time difference between the server and the client. So this is a failsafe to make sure that at least some time has passed. Vector y is a sinal curve, so what the barrel is going to do is go up and then go down. So it's a sinal curve. And I've added 5, multiplied by 5, so it goes 5 meters up in the air. And then what this is going to do is say if basically the sine curve has ended, so now it's either less than or equal to 0. And again, just catching the differential. If you don't have that here, it'll almost never return. So add this for a differential check. What it should do is set time and vector to 0, basically back to the home position. I should probably put this back to the height map height, not 0, but for now that's okay. Set matrix will again take this new y vector value and apply to the matrix. And this is important that after the kinematic move matrix, this will move, so this piece moves the mesh, this piece will move the entire actor. So you want to do these both, or else you'll have just the mesh moving or just the actor moving, which is important there. So I think that's actually the last of it. Now in order to add a new class, we have to do certain other things as well. So in the objects objects here, you need to set the object type. And we want to call it jumpers. We call it what do we call it? So actually, I already created a class. So you need to do this as well. You need to create a object class. here called object jump. So it doesn't have anything in it, but make sure you create it so that it has a thing there. So obj jump. So anything of type object jump will load in, and the barrel that I created, you can see, is of type object jump. So that will load it in correctly. And in my world, I'm now going to add that. So now in my world, you've seen this in my other tutorials, I'm just going to drop in one of these barrels. Anywhere is fine, so put it right there. So now I have that in. That should do it. Cross your fingers. So let's try and compile, see what happens. That was lucky. Alright, first try. Let's see if the client compiles. Alright, where's my barrel? Oh, there it goes. You can see it jumping too. We just missed it. So it looks like it's working. There's my little barrel. It's collidable. I should be able to stand on it. And every 20 seconds, this bad boy should raise up into the air 5 meters and then drop back down again. So if you bear with me for just a few seconds. Oh, there we go. Some collision issues, but yeah, that seems to have worked. So it's a good start. So we added a brand new actor to our world using scheduler. We've made him jump every 20 seconds, and we've updated on both the client and the server, so they both will stay in sync. I think it's a good place. There we go. It looks really good. The trees are still changing. My camera is still there and moving around, so not a bad day for tutorials. My name is Osmodian. You can always find me on the Esenthel forums. And if you have any questions, feel free to shoot me a PM or a post. Have a great day. Thanks a lot. Bye.